All right, so today's video is going to be on the notes about laws of exponents. This is page 52 in your notes. So you should be doing this probably on Friday, I think. Friday or Monday, one of those two. All right, so at the beginning, before we actually get into the laws of exponents, we're going to do a little review on the difference between saying 3x and x cubed. Then we're going to get into the parts of an exponent, and then we'll get into the exponent laws. So at the top, the first question is asking, what is the difference between saying 3x and x cubed? So just in your own little brain, think about what's the difference. And if you know the difference, if not, I'll tell you in a second. So take a couple seconds and think about it. What's the difference between 3x and x cubed? Hope you like my thinking music. All right, so hopefully you recognize that 3x is the same thing as saying there are 3 x's that are being added. So x plus x plus x, that's 3x. And x to the third, or please don't say x3, it's x cubed or x to the third, is the same thing as saying x times x times x. And these two are vastly different. These are not the same thing. One is addition and one is multiplication. So, for example, if we were to pick any random x, let's say x equals 4. If we plug 4 in, because remember, this will be substituting in 4 wherever we see x. So if we were plugged 4 in here, this would be 3 times 4, which ends up being 12. Whereas if we plugged 4 in here, 4 cubed would be 4 times 4 times 4. So that would be 16 times 4, which is, I don't know, what's 16 times 4? Let's take our little handy dandy calculator and we're going to figure that out. So to get 4 to the third power, we're just going to hit the number button 4. And then to get third, we're going to use the caret button. It's this button right here. It looks like a mountain. It's called a caret. It's that way in English too, just in case, for your information. We're going to hit the caret button. And then you see how it gives it an upper, what's that thing called, Johnny? A subscript or a superscript? Superscript, right? It's called a superscript. I'm totally awesome. And we want 3 to go here, so we're going to hit the number 3. So that way our calculator will do 4 to the third power. So 4 cubed is 64. So as you can see, these are different operations. So I don't want you to get confused 3x and x cubed. This is just saying there are 3 x's being added. This is saying there are 3 x's being multiplied, okay? Now let's talk about the parts of a term. So this right here, 4x squared, this would be called a term. And every term consists of a coefficient, a base, and a power. So the number that's in front of the variable, that is called the coefficient. Coefficient. All right, so this is telling you how many of those x's are being added together, basically, or 4 times whatever that x is. The x itself is called the base. The variable is called your base. And then the tiny number up at the top, the superscript, that's called the power, or it is also called your exponent. Exponent. And every single term has all 3 of these. Now, if we just had x by itself, x still has a coefficient and a power, we just don't actually write them. So it's understood that if there's not a number in front, the coefficient is 1. And it's understood that if we don't see a tiny number and we have a variable, that tiny number is also 1. Okay, so that's just something that you have to also be aware of. So if you don't have a number in front of a variable, that's 1. If you don't have a tiny number and you have a variable, that's 1 as well. Okay, but every term will have one of these. Okay. All right, so now let's talk about the laws of exponents and kind of take a look at some of these. All right, so what we're going to do is we're going to look at the examples, and I want y'all to try to figure out what is happening, and that way we can come up with a rule. Okay, so I'm going to give you a couple of seconds. So if you want to pause the video right here and just think, how can you go from here to here? I'm going to give you like a minute or two. Well, no, you give yourself a minute or two, then come back. Okay, so hopefully you took a second and you were kind of able to figure out what's going on. So let's look at this first example. We've got x squared times x cubed equals x to the 5th. So how would we be able to get 2 and 3 to make 5? Hopefully you notice that if you add 2 and 3, we should get 5. Okay? All right, so let's take a look at this one. We've got x to the 4th times x to the 7th, and then that gives us x to the 11th. So how would you get 11 from 4 and 7? Well, 4 plus 7 gives us 11. So, let's think about that. So what could be a rule? All right, so let's kind of break it down. If in your head you kind of figure out what's going on with the tiny numbers or the exponents, that's cool, but let's figure out why that happens. All right, so we've got x squared. Now up at the top, we said that x cubed was the same thing as saying x times x times x. So if I have x squared, that's the same thing as saying x times x. Two x's are being multiplied. Then I'm multiplying that by x cubed, which would also be x times x times x. So when we expand it out, we see that x squared times x cubed is just x times x times x times x times x, which there are a total of 1, 2, 3, 4, 5 x's. That's how we get x to the fifth. All right, over here, same thing. There are 4 x's being multiplied times 7 x's. 1, 2, 3, 4, 5, 6, 7. So at the end, how many x's are being multiplied? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's how we get x to the 11th. All right, so now that's if we just have our variables and exponents. Now let's talk about when we have coefficients. Right? So I know that with my x's, I've got x times x, and here I've got x times x times x, but I also have 3 times those 2 x's and 4 times these 3 x's. What we're doing here, the operation is actually multiplying. So what if we actually multiplied 3 times 4? What do you get? Well, hopefully you said 12, because that's the right answer. It would be special if you didn't, but you know, some of y'all are, so it is what it is. So if I do 3 times 4, that's what gives me 12. And then I've got 1, 2, 3, 4, 5 x's, and that's how we get that. Okay? Same thing over here. I've got 5 times x times another x. So I've just got the number 5, which is where that comes in, and then there are 1, 2, 3 x's. So if you can come up with a rule in your own words, I want you to write that here. You can say we can expand and multiply the coefficients, or if you can come up with an easier way to do this, I'm cool with that too. So I want you to take a minute, pause it, and do these two here, and then we'll be back to see if you have the right answer. All right, so hopefully you took the time to pause the video and do these problems on your own. So if you have 6r times 5r squared, 6 times 5 would be 30, and then you've got 1, 2, 3 r, so this should be r cubed. All right, example number 2, we've got 2 times 2, that gives me 4. I've got 1, 2, 3, 4 n's, and then 5, 6, 7 more, 3 more n's gives me a total of 7 n's. Now, if you notice, I'm using dots instead of writing it all out. If that's helpful to you, do so. I just don't have a lot of room here. So I've got a total of 7 n's. So you should have had 4 into the 7th. Cool. All right, now let's take a look at example number 2. So here we go. I've got x to the 5th divided by x cubed equals x squared. And then down here we've got x cubed divided by x to the 7th equals 1 over x to the 4th. That one's kind of a little more trickier. You've got 5x to the 9th over 15x equals x to the 8th over 3, a little bit more difficult. And then 6x to the 9th over 3x to the 5th equals 2x to the 4th, slightly more difficult. So as you notice, we're kind of getting more and more taxing on your little brains, but it's cool. I believe in you. You can do this. So try to do the expansion thing. Now this line right here, remember I told you, the line means to divide. Remember, a fraction just means something on top is being divided by something on bottom. So keep that in mind when you try to do this on your own. So go ahead, take a break or pause the video, see if you can kind of figure it out, and then we'll be right back. All right, so let's talk about these. All right, on top, we're going to expand just like we did over here. So if I have x to the 5th, that means I've got 5 x's being multiplied on the top. On the bottom, you've got x to the 3rd, which means we've got 3 x's being multiplied. Now, who remembers what something divided by itself is? If you have 2 divided by 2, what is it? If you have 3 divided by 3, what is it? If you've got 9 divided by 9, what is it? Hopefully you said 1, because we've done that a million times in class. Those that are new to my class, hopefully whoever you had last semester taught you that too. But whatever, it's cool. I'm going to learn you something new today, if not. Anytime you have a number and you divide it by itself, it's going to give you 1. 2 divided by 2 is 1. 4 divided by 4 is 1. A million divided by a million is 1. So if I have x divided by x, it's 1. So x divided by x is 1. X divided by x is 1. X divided by x is 1. So it kind of, they don't really cancel out. It makes 1, but 1 times anything is itself, so they kind of just go away. And all I'm left with is 2 x's up top. So that's how you get that x squared. And technically it's x squared over 1 because any whole number is over 1. We've learned that as well. But we never write it. So it just ends up being condensing to x squared. Okay? Let's take a look at the one on the bottom. So you've got 3 x's on top, 2, 3, and 7 on bottom. 1, 2, 3, 4, 5, 6, 7. So again, x divided by x is 1, 1, 1. And I don't have anything left on top, but this is 1 times 1 times 1, which is 1. And then I've got 4 x's left on bottom. So that's how we get 1 over x to the 4th. Cool. All right, hopefully that didn't blow your brain. Let's take a look at the more harder one. So now on top I've got 5 and then 9 x's, 2, 3, 4, 5, 6, 7, 8, 9. And then on bottom I've got 15 and 1x. So you already know that 1 divided by 1 is 1, or x divided by x is 1. So that cancels out the only x that was down here. Now let's talk about that 5 divided by 15. So in your calculators, we're going to put in alpha y equals enter to get that fraction, and I want you to do 5 over 15. Don't do the division thing, because then it won't simplify your thing. It'll give you a, what's that crap called? A decimal, thank you. So if you hit enter, it's going to simplify your fraction. So you've got 1 over 3. So this is going to be simplified to 1 over 3, and then you've got 1, 2, 3, 4, 5, 6, 7, 8 x's that are on top. Well, 1 times 8 to the x just ends up being x, 8 to the x, I'm special, x to the 8th over 3, and that's how they got that answer. Does that make sense? Hopefully so. All right, and then the last example, it's the same exact thing. What is 6 divided by 3? Again, alpha y equals enter. Do 6 over 3. If you can do it in your head, awesome. Good job, you. If not, calculator. So 6 divided by 3 is 2. Which is where we get that from. And then you've got 9 x's on top. 2, 3, 4, 5, 6, 7, 8, 9. I should have used less than x's when I made this up. My bad. This is awful. 2, 3, 4, 5. So that cancels, 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 cancels. You're left with 4 x's on top. So you've got 2x to the 4th over 1. Okay, so we just don't ever write the 1, but it's there. All right, so over here, I kind of want you to make a synopsis of what you had to do, and if you find an easier way, do that, and then do the 2 practice problems. Take a couple of seconds, we'll be right back. All right, so let's talk about the answers that you got. So if we were to expand this, we would have 9 and then 5 x's. Then we have 3 and 2 x's. So deal with the whole numbers first. 9 divided by 3, that's going to be 3. Remember, it'd be 3 over 1, so we're just going to keep that in mind. Then we have these x's kind of cancel out, and you've got x cubed left on top. So since the only thing that's left on bottom is a 1, then we don't need to write that. So the answer will be 3x cubed. Okay? All right, example number 2. You've got 2 and then 7 s's, 5, 6, 7, a 6 and 5 s's, 3, 4, 5. So we're going to deal with the 2 over 6. So again, we grab our calculator. And I'm going to go up and highlight and hit enter again because I don't feel like hitting alpha y equals because I'm slacker. All right, what do we got? 2 over 6. So 2 goes on top, 6 goes on bottom, and that reduces to 1 over 3. So I know that I'm going to have a 1 on top and a 3 on bottom. Then these cancel out or become 1s, and I'm left with 2 s's on top. 1 times anything is itself, so this would just be s squared over 3. And that would be the answer. So hopefully y'all got that right. If you did, good job. Proud of you. If not, quit being a slacker. Get your stuff together. All right, so let's go to the back side. All right, back side, next rule. Here we go. So take a look at your examples. Give you a couple seconds. How do you think we went from this 2 and 3 to 6, 4 and 3 to 12, 6 and 4 to 24? Just kind of take a look, see what's happening. All right, so what this is saying is that the quantity x squared is cubed. So remember, if we had had x cubed, that's the same thing as saying x times x times x. Well, we've got the same thing here, only instead of it being just an x that's cubed, it's an x squared that's cubed. So this is like saying x squared times x squared times x squared. Right? But then we can even break it down farther because in x squared we have 2 x's. This is 2 x's and this is 2 x's. So we have a total of 1, 2, 3, 4, 5, 6 x's being multiplied. So that's how you get x squared. All right, same thing over here. There are 3 y to the fourths. So y to the fourth times y to the fourth times y to the fourth. Well, in that y to the fourth, that means there are 4 y's that are being multiplied. Then we have a second set of y's. Then we have a third set of y's. So there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 y's. Does that make sense? Hopefully, kind of, sort of. All right. So now, down here, when you're dealing with larger numbers, it might be a pain to write all of them out. So hopefully, y'all are already coming up in your head with what's going on and how to get to it. But if not, we'll expand. Expansion is always your best bet, okay? All right, so we've got 4 are 6's. 3, 4. So there are 6 r's. Oh, I don't want to write 6 r's. Ah, it's so long. Okay, here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. See, this is where it gets kind of troublesome, is when we get these long things, it kind of stinks to not have a shorter method, but I'll tell you all about that in a minute. So for right now, just go ahead and count them up. There should be a total of 24 y's. Now notice, there's nothing on top but a 1. That will not change, because we didn't do anything at the top. We just expanded the bottom. So that still comes out as 1 over y to the 24th. All right, now last problem. So we have 3x to the 5th squared, which means there are 2 3x to the 5ths. 3x to the 5th. And now it's more like a problem on the front side of the thing where you've got 3 times 3, and then you've got 5 x's, 4, 5, and then another 5 x's. So what would be 3 times 3? Well, that's 9. And how many total x's? There are 10 of them. So that's how they got that answer. All right, so just like on the front side, take a couple minutes, think about what happened, kind of write a synopsis up here, and then try these 2 here. All right, so hopefully you had some time to try to find the answer on your own. So let's talk about this. So just like we did in this example here, you've got 2x squared to the 3rd, which means there are 3 2x squareds. So that means 2x squared times 2x squared times 2x squared, right? Now, 2 times 2 is 4. 4 times 2 is 8. So that's going to be your coefficient in the answer. And now you've got x squared times x squared times x squared. Now remember, x squared just means x times x. So there are 2 x's, there are 2 x's, and there are 2 x's. So you've got a total of 2, 4, 6 x's. X to the 6th should be your answer. Oh, over 1, or under 1, I should say, because that 1's still on top. We didn't do anything to that. Okay? All right, example number 2. There are 5 4y cubes. So 4y cubed times 4y cubed times 4y cubed times 4y cubed times 4y cubed. So you've got 4 times 4 times 4 times 4 times 4. Now I don't expect you to know how to do this in your head, so hopefully you used your calculator, because I had to use a calculator as well when I'm doing this, because I'm not that great or that smart. So here we go. You've got 4 times 4 times 4 times 4 times 4. So there are 5 4's. So see, 5 4's that are being multiplied. So what's that? Oh, good grief. 1,024. That's a huge number. All right, so our coefficient is going to be 1,024. And then we got to figure out how many y's we have. We've got 3, 3, 3, 3, 3. So what's 3 plus 3 plus 3 plus 3 plus 3? So calculator. 1, 2, 3, 4, 5 sets of 3. So it'll be a total of 15. So it'll be y to the 15th. Okay, so this will be your answer on that one. Hopefully you got that right. If not, get yourself together. I don't know what else to tell you. All right, cool. We'll do some more practice on it. You'll be okay. All right, last example. Now, on this last example, we're dealing with negative exponents. All right, so we wouldn't say this is x minus 2. This is x to the negative 2. Or would you say x negative squared? Squared negative? Just negative 2, right? All right, that's what I thought. All right, so this would be x to the negative 2. All right, now, with exponents, we do not like negative numbers. Just like we don't like it when, I don't know, what do I say that's bad grammatical error? Oh, we don't like saying 2 plus a negative 3. Even though that is technically correct, it's not mathematically correct, or mathematically grammatically correct, whatever it is I normally say. We like to say 2 minus 3. We don't like to say plus a negative. Same thing down here. We don't like negative exponents. So in math, we want to get rid of them, okay? And there is a rule for that. So if you'll notice, x to the negative 2 becomes 1 over x squared. Over here, I've got x to the 5th, y to the negative 6th. It becomes x to the 5th over y to the 6th. Down here, s cubed over r to the negative 7th becomes r 7th s3. And then you've got g to the negative 3h over 3f to the negative 5th. As the end result, you've got f to the 5th h over 3g cubed. So, taking a look, what do you think we're doing to get rid of those negatives? So just take a second and look, see if you can kind of figure out what's happening. Oh, wait. Maybe turn to a partner if someone's in the room and they don't mind you asking them questions, see what they got. I don't know, do something special. All right, so hopefully you had time to think about it and you kind of came up maybe with the right answer. We'll see. All right, so on this first example, we have x squared as kind of like a whole number. It's not a fraction because we have nothing there. Now we could say it is over 1, right? Because remember, any whole number is automatically over 1. Take a look at what the answer would be. How did we make it positive? Where did the x squared, or x to the negative 2, where did it go? So if you're looking at the answer, it went down underneath that line, right? So if we take a negative number and go to the opposite side of the fraction line, that makes it become positive, right? Well, what's left on top? If that x squared goes away, there's technically nothing left on top, right? So we have this 1 as kind of like a placeholder to kind of keep it there, right? So draw your line, take the negative to the bottom side, and it becomes positive. And you don't have to do anything to it mathematically, just take away that negative, right? All right, so take a look down. Well, let's do this one because it kind of is the same thing. So x to the 5th is positive, y to the negative 6th, that's your negative one. So if you draw a line, make this go down here, you still have that x to the 5th up top, but now y to the 6th is on the bottom. So hopefully that's kind of making sense for you. So if you have a non-fraction, just draw your line, and the one that's negative, make it go below. All right? Now, if you already have a fraction, like this one here, it's the same type of thing, except for if the negative number is on the bottom of the fraction, if you move it up top, it makes it into a non-negative. Oh, that's a horrible way of saying that. But it goes from negative to positive because we're flipping to the other side of that fraction line. So this is still technically a fraction, but since that r to the negative 7 is gone, that placeholder is then 1. But do we ever write over 1? No, it's just understood that that's that. So this would just be r to the 7th s cubed, not over 1. We could write it, it's understood, but we don't write it because it's just, you know, grammar and whatnot, math grammar. So now this was the harder one. We've got two negatives. You've got a negative on top and you've got a negative on bottom. But the h and the 3 are positives. So notice the h and the 3, they are still there. They did not move. So that g, because it's negative, had to go below, and the f, because it's negative, had to go up top. Now, f is now in front and g is now behind. Well, why is that? So just like that math grammar, we like to say things in a certain way. It's the same thing here. Whenever we write variables, they have to be written in alphabetical order, right? So even though h was already up here and technically it was there first, it won't be first because alphabetically f comes before h. So that f to the 5th will be written in front. And then on bottom, coefficients always come first. That's just the rules. Unless it's being added or subtracted, then they're always last. It's a constant. We'll get to that later. But if it's being multiplied, the coefficient, the big number, goes in front. So then you have 3g cubed on the bottom. So hopefully that's understand. If you don't know, just ask the math teacher in the room. They'll explain it better than me. Suckers, what's up? Just kidding. Ask the math teacher in the room. It'll be better. So now, take a look over here. Kind of get a synopsis of what you got to do. You can write it in here. We'll come back and fill those in later. See if you can do these on your own. All right, take a couple minutes. All right, so hopefully you were able to kind of at least try to get the right answer. So I was talking with Miss Johnny, you know, my cool friend next door. She said that the best way that she remembers it is that, do you remember when we have like x plus y equals 12 and we want to solve for y? Well, we change the x, when we change the side, we change the sign. Same thing with negative exponents. We change the side of the fraction, we change the sign of it. So that might be a better way to kind of help you remember it. So let's work on this. We've got p to the negative 10th. It's not already in a fraction. So draw your line. We're going to change the side, then we change the sign. So then it becomes p to the 10th below, no negative. But remember, since we had to make a fraction and p to the 10th isn't below, there's nothing left up here. We have to have a placeholder. So we're going to put 1 there. All right? Same thing down here. Change the side, change the sign. We have to do both for the S and the T. So I'm going to have the 2 left on top and the R left on bottom. And then the T is going to go up top, change the side, change the sign. The S goes to bottom, change the side, change the sign. Then check and make sure it's in alphabetical order. A, B, C, D, F, G, wait, element of P, Q, R, S. All right, that's correct alphabetical order, so we're good to go. Yay. All right, so now we're going to talk about